Tangent and cotangent functions. What is the tangent function and cotangent function? So let's see. So first, let's remember tangent and cotangent from right triangle. So if you have a right triangle ABC and angle x here, tangent is opposite over adjacent. Cotangent is adjacent over opposite, yes? Or from the identities formulas, we know tangent x is sine x over cosine x. Cotangent x is cosine x over sine x. So these things we have learned. Now let's see the tangent and cotangent functions on unit circle. So first one is tangent function. So see here we have a unit circle and here we have a tangent axis. So tangent axis is always on x1. So here is x is 1. And so tangent axis is always parallel to y-axis. Then let's say we have a angle alpha, and this angle alpha is intersecting with the tangent axis at the point P. And this distance from x-axis to P is the tangent alpha. So this distance will be the tangent alpha. And see here, in first quadrant, tangent is always positive. So all values of tangent in the first quadrant will be positive. In the second quadrant, so see here, our alpha is this one, yes, this angle, and it's in the second quadrant. It's tangent, so it's not intersecting with the tangent axis, but its extension is intersecting with the tangent axis. So we can find, so this angle and this angle are equal, so we can calculate this tangent is equal to the tangent of alpha. And then, so see this distance will be the tangent alpha. And in the second quadrant, all values of tangent are negative. So in second quadrant, shortly we can say tangent is negative. In, let's see, in third quadrant. So in third quadrant, again, so see here, we have alpha, yes, and then its extension is here, and it's intersecting again with the tangent axis here, and then so the values of tangent in third quadrant is positive. In fourth quadrant, again, so tangent, this is our angle, so from 0 to here, it's like that, yes, so this is our angle. And then it's intersecting with the tangent axis here, and this distance will be tangent alpha. And you see here, so in fourth quadrant, tangent is negative. So because it's this distance is under x-axis. Then let's continue. So see here, we have again unit circle, and so let's see in which quadrant tangent function is increasing. Is it decreasing? Is it positive or negative? Now let's continue. So in first, so see here, I will show you 3 different angles. So as you remind that notice here, when angle is increasing, the values of tangent are also increasing. So see here, this is the first angle, yes, it's tangent. So here, this angle is smaller, maybe it can be 30 degrees, yes. So 30 degrees, let's say this is a 45, so we can write, so to understand, so it can be 45. So this will be 60 degrees, yes. So we see here, when the angle is increasing, tangent also increasing. So, and one more thing, when angle is 90 degrees, so it's parallel to tangent x, and it will never intersect. They will never intersect. So that's why on 90 degrees, tangent x, or tangent alpha is tangent of 90 degrees is undefined. And so we can write for first quadrant, tangent is positive, it's increasing from 0 to infinity. So here we don't know, so they will never intersect, so that's why it's infinity. Then let's see for second quadrant. So in the second quadrant, again, I will draw 3 angles, yes. So let's write again. So this can be 120. So this can be, it's just example, 135. This can, again, 150 degrees, yes. Now see here, so 120, so here it is negative value. So here maybe it is, let's say a, so but it will be negative a because it's under x-axis. Now second one, 135, its tangent is, let's say, b, but again it's minus b. And the last one, yes, it's here. So let's write it is c minus c. So here the smallest one is minus 1, then minus b and minus c. So here tangent again anyway increasing, it's approaching from minus infinity to 0. So in second quadrant tangent is negative, but it's increasing, it's approaching from negative infinity to 0. So this was the second quadrant. Now let's see in third quadrant. Again, 3 angles here. So you can write here, for example, 210, 200, which what we can write, 225, yes, and 240, yes. So see here, when it is 210, so it's here, yes. So let's write it, say 225, its tangent is this distance, so that's why it's b. Let's write 240, its tangent is, let's say, c. So here the greatest one is c, and then b, and then a. So again in third quadrant, yes, tangent is increasing. Tangent is increasing, and it's from 0 going to infinity. So that's why in third quadrant also tangent is increasing. Then let's see the fourth quadrant. Again, 3 angles. So you can write, so it can be 300 degrees, yes, 350, 315, and this one 330. That's right. So here again, let's write this distance is a tangent of 300 degrees, so that's why let's write minus a, so it's negative. Next one is the tangent of, so this distance is a tangent of 350, it will be minus b. This distance is tangent of 330, it is minus c. So here the smallest value is minus a, minus b minus c. So in fourth quadrant also, this tangent is increasing, and it's increasing from minus infinity to 0. So it's approaching from minus infinity to 0. So in shortly, we can say in all quadrants, tangent function is increasing. So in first and third, it is positive. In second and in fourth, it's negative. But in all quadrants, tangent is increasing. Now, let's here, values of the tangent is from minus infinity to positive infinity. Now, let's do some examples. So here, these are given. X is tangent 37, y is tangent 36, z is tangent 35. Now, if we know that, so tangent is always increasing. So in first quadrant, yes, in first quadrant, tangent is positive and increasing. So here we need to compare the angles here. So first, 35 is the smallest one, yes? And then 36. And then 37. So here, the smallest one is when the angle is increasing, tangent also increasing. So here we can write tangent 35 is the smallest. So tangent 35 is the smallest. Then tangent 36. Then tangent 37. So we can write z is the smallest, then y, then x. So this is all about the tangent function. Now let's see the cotangent function. So again, cotangent function. So here, unit circle, and our cotangent x is when y is 1. Then, what is the cotangent of alpha? So again, we have a angle alpha, and it's this angle is intersecting with a cotangent axis at a point P, and this distance C is a cotangent alpha. So in the first quadrant, cotangent alpha is positive. So here it will get positive values. And then in the second quadrant, cotangent, so here it's on the left side of the origin, so that's why it is negative. So cotangent alpha in the second quadrant, it is negative. Now in the third quadrant, cotangent, so its extension is here, extension is on first quadrant, so that's why in third quadrant cotangent is positive. In fourth quadrant, again its extension, so angle's extension is on second quadrant, so that's why in first quadrant also cotangent is negative. Now let's see cotangent function is increasing or decreasing. Now again I will compare three angles in the first quadrant. So firstly, I want to show you here. So when angle is 0, so here when angle is 0, this angle and cotangent axis, they are not intersecting. So that's why in a 0 degree it's undefined. And then, so let's write here 30 degrees. Yes, first angle. This is 30. Let's change the color. this is 45, this is 60. Then, so see here, you see yourself, when angle is increasing, cotangent is decreasing, so bigger, smaller, smaller, yes? So cotangent is decreasing. In first quadrant, cotangent is positive, but it is decreasing. It is decreasing from infinity to 0. So from positive infinity, it's going to 0. So in second quadrant, again 3 angles I will compare. So when angle is increasing, its values of the cotangent is again decreasing. So here, for example, here it will be minus a. Here cotangent of the next angle will be minus b. Cotangent of the third angle can be minus c. But we know that minus c is the smallest one here. Minus a. So that's why cotangent is again decreasing. So it's approaching to minus infinity. And again on 180, this angle and cotangent x they are not intersecting, so that's why it's undefined. So in the second quadrant, cotangent x cotangent is decreasing. It's negative and it's decreasing. It's approaching from 0 to minus infinity. Now let's see on third quadrant. So again, in third quadrant, first angle again can be, yes, 210, for example, 225. So it can be 240. Yes. So see here, 230 is the cotangent of the 210 is greater. 225 is smaller. Yes. So 240, the smallest one here. So when the angle increasing in the third quadrant, cotangent again decreasing. So it's decreasing from positive infinity to 0. And on the 270, so here cotangent is 0. Then continue for fourth quadrant, again 3 angles. So here when angle is increasing, yes, again cotangent is decreasing, so it's moving to negative infinity. So that's why in fourth quadrant cotangent is decreasing. It's decreasing from 0 to minus infinity. So in fourth quadrant cotangent is negative, it's decreasing, and it's approaching from 0 to minus infinity. So here we see all about the cotangent function. Now let's do some examples here. Write each given trigonometric values in ascending order, so from smaller to bigger. Now, so values are given in pi. Now we should compare these angles. Now let's find 5 pi over 9. Let's write them. 2 pi over 3 and 7 pi over 9. Now here, as you see, so this has a different denominator. To compare them, we should have same denominator. So to equalize this denominator, I should multiply this angle by 3. Then I will get 5 pi over 9. So this will be 6 pi over 9. And this is the 7 pi over 9. So if I compare the angles, yes, so this is the greatest one, this is the smallest one, yes. But cotangent function, when the angle is increasing, cotangent is decreasing, yes. So that's why the cotangent with the smaller angle will be the greater, yes. So cotangent 5 pi over 9 is the greatest one. Cotangent 6 pi over 9, the next one, and then the smallest one is cotangent 7 pi over 9. So here A is the greatest, then B, then C.